Good morning, everyone. Today I'm going to present the topic plotting in data exploration and visualization, which plays a key role in data science and machine learning. Data explorations is the initial step of data analysis. It helps us understand the structure of the data, identify patterns, and detect errors. Through data exploration, we can find trends, missing values, and outliers, which is necessary before performing further analysis. Data visualization is the process of representing data graphically. It makes complex data easy to understand and interpret. Plotting is the core technique used in data visualization to convert numerical data into visual form. Plotting is important because it allows easy interpretation of data. It helps in identifying patterns and trends, supports decision making, and improves machine learning model performance by understanding the data better. In data exploration, we commonly use the following plots such as line plot, bar chart, histogram, scatter plot, and box plot. Each plot is used based on the type of data and the analysis requirement. A line plot is used to show trends over time, for example, monthly temperature changes. Line plots are widely used in applications such as stock prices, rainfall analysis, and sensor data monitoring. This diagram is a line plot that shows the population changes of Ireland and Europe over a period of time. The x-axis represents the years, which shows how the population changes over time. The left y-axis, shown in green, represents the population of Ireland in millions, while the right y-axis, shown in blue, represents the population of Europe in millions. Two different y-axes are used because the population of Europe is much larger than that of Ireland. The green line indicates Ireland's population trend. Initially, the population increases steadily, then shows a sharp rise, reaching a peak in the middle years. After that, there is a decline followed by small fluctuations, and finally, a gradual increase towards the end. The blue line represents Europe's population trend. It shows a continuous and steady increase throughout the time period with faster growth in later years. From this graph, we can conclude that Ireland's population fluctuates while Europe's population grows steadily over time. This diagram clearly demonstrates how a line plot is useful for analyzing trends and comparing changes over time. Next one is a bar chart. A bar chart is used to compare different categories. For example, comparing the number of students in different departments. Bar charts are commonly used in sales comparison and population analysis. This diagram is a bar chart titled Flavor Preferences by Gender. The x-axis represents different ice cream flavors, namely chocolate, strawberry, and vanilla, along with gender categories. The y-axis represents the count of people who prefer each flavor. In the chart, pink bars represent female preferences and blue bars represent male preferences. For the chocolate flavor, females show a higher preference compared to males. For the strawberry flavor, both males and females show almost equal preferences. Overall, for vanilla flavor, males show a significantly higher preference than females. Overall, the bar chart clearly shows how flavor preferences vary between genders. This diagram demonstrates how a bar chart is useful for comparing categorical data across different groups. Next one is a histogram. A histogram represents the frequency distribution of continuous data using adjoining bars. Unlike a bar chart, the bars in a histogram do not have gaps. For example, marks distribution of students. Histograms help detect skewness in data spread. This diagram is a histogram that represents the age distribution of people. The x-axis represents age groups or age intervals such as 20 to 30, 30 to 40, 40 to 50, and so on. The y-axis represents the frequency, which shows the number of people in each group. Each bar represents the count of people whose ages fall within a particular range. From the histogram, we can observe that most of people fall in the age range of 40 to 60, where the bars are tallest. Fewer people are seen in the lower age group 20 to 30 and the higher age group above 70. The bars in the histogram touch each other, indicating that the data is continuous. This histogram helps us understand the distribution, spread, and concentration of age values. Hence, the histogram is useful for analyzing continuous numerical data. Next one is a scatter plot. A scatter plot shows the relationship between two variables, for example, study hours versus marks. It helps identify correlation between variables and is widely used in machine learning feature analysis. This diagram is a scatter plot that shows the relationship between diameter and height. The x-axis represents the diameter in centimeters and y-axis represents the height in meters. Each point on the graph represents one observation, showing a pair of diameter and height values. From the scatter plot, we can observe a position correlation between diameter and height. This means that as the diameter increases, the height also tends to increase. The straight line drawn through the points represents a trend line or line of best fit, which summarizes the overall relationship between the two variables. A few points lie slightly away from the line, indicating natural variation or minor outliers. This type of plot is very useful for identifying relationships, correlations, and patterns between two numerical data variables. Next one is a box plot. A box plot shows the data spread and outliers. It displays the minimum, maximum, median, and quartiles. Box plots are mainly used for anomaly detection and comparison of distributions. This diagram represents a box plot, also known as a box and whisker plot. A box plot is used to show the distribution of data, including its spread, central value, and outliers. The box in the diagram represents the interquartile range, which is the range between first quartile and the third quartile, that is Q1 and Q3. Q1 is also called the 25th percentile, indicates that 25% of the data lies below this value. Q3, also called the 75th percentile, indicates that 75% of the data lies below this value. The line inside the box represents the median, which is the middle value of the dataset. The whiskers extend from the box to the minimum and maximum values within the range of 1.5 times in the IQR. IQR is nothing but the interquartile range. The points shown outside the whiskers are called outliers, which represent unusually high or low values. This box plot helps in detecting outliers, understanding data spread, and comparing data sets. Outliers are data values that are much higher or much lower than most of the other values in the data set. They deviate significantly from the general pattern of the data. And these are all the tools, various tools that are used for plotting and visualization, such as Matplotlib, Seaborn, Excel, Tableau, and Power BI. These tools help create effective visual representations of data. To conclude, plotting is essential for understanding data clearly. It supports better analysis and modeling and is an important step in the data science pipeline. Thank you.